Hi everyone, Coach Peaks here. Today we are going to learn something called prime factorization. So we already know what factors are, but what about that word prime? What does it mean? So basically a prime number is just a number that has exactly two factors, one and itself. So for example, let's take the number 7. I want you to think about what numbers can I multiply together to get 7. That's right. Hopefully you thought about 1 and 7. Can you think of anything else? No? Okay, that is what makes it prime. The number 7 can only be found by multiplying 1 and 7. That is it. So what is so special about prime numbers anyway? Why do we need to know about them? Well, prime numbers are like the building blocks of all the other numbers, all the other whole numbers. So in fact, whole numbers that are not prime are also called composite numbers because they are composed of prime numbers. Composite, composed, same word. So that means that you can get composite numbers by multiplying prime numbers together. Mind blown, right? Okay, let's get into our notes. Hopefully you have printed them out or you're following along in Cami. So a prime number has factors of only 1 and itself. 1 and itself. So our first blank, you need to write the word itself. So for example, 3. The only way that we can get to 3 is 1 times 3. Or if you wanted to flip it around, that's the same thing, 3 times 1. So those two ways are the only ways to compose 3, 1 and 3. So that's our example of a prime number. Now, a composite number is a whole number that has factors other than 1 in itself. So let's write factors in that blank. So a whole number that has factors other than 1 in itself. So for example, let's think about 8. What numbers can I multiply together to get the number 8? Okay, 1 times 8 and 2 times 4. So the factors of 8 are 1, 2, 4, and 8. So notice a composite number has more than 2, more than itself and more than 1. So what we are going to do next is we are going to circle all of the prime numbers and we are going to box all of the composite numbers. So I'm going to do the first few with you and then you're going to have an opportunity to try yourself. So let's look at number 18. In order to determine if this is a prime or a composite number, I need to ask myself, what are the factors? What can I multiply together to get 18? So of course, 1 times 18, but anything else? Exactly, you can do 2 times 9. Okay, so because we can multiply it, or we can get 18 by ways more than 1 times 18, it is a composite number, so I'm going to box it in. Let's do number 5. So I want you to think about what can I multiply together to get 5? Hopefully, the only factors that you got were 1 and 5, which makes it a prime number. Let's look at number 7. What can I multiply together to get 7? That's right. Only 1 and 7. Let's do 20. So what can I multiply together to get 20? I have 1 times 20. Anything else? Absolutely. 2 times 10, 4 times 5. So because we have more than 1 in itself, it is a composite number because it is composed of multiple prime numbers. Okay, let's try the next one, 22. So what can I multiply together to get 22? Right, so 1 times 22. Anything else? Hopefully, you're thinking of 2 times 11. So that makes it a composite number. Let's do number 9. What can I multiply together to get the number 9? So we have 1 times 9 and 3 times 3. So it is a composite number. Let's try 16. What can I multiply together to get 16? 1 times 16, 2 times 8, 4 times 4. So that makes it a composite number. So hopefully this is starting to make sense just a little bit, but what I would like for you to do is pause the video, finish out this portion of the notes, and come back to see if you get the right answer. So hopefully you're back and you are checking your answers. As always, if you made a mistake, that is completely okay. Erase it and make the adjustment that you need. We are not going to specifically go through each of these numbers, but just take away that if there is a number that only has factors of 1 in itself, you can only get to that number by multiplying it by 1, then it is prime. And a number that has multiple factors other than 1 in itself is called composite. Okay, so now we are going to use something called prime factorization. Okay, so it says to determine the prime factorization of a number, we must break down a number into its factors. The second step is we continue until all of the factors are prime numbers. And also, prime factorization is written in exponent form. Now, we have talked about exponent form before on Monday. So if you have questions with exponent form or you don't remember, I would highly suggest going back and looking at Monday's notes to check that out. So we are going to use prime factorization to find the set of prime numbers that make up our composite numbers. And all that means is we're going to continue to factor the composite number until all of the factors are prime numbers. Now, to do this, I'm going to use something called a factor tree. And all a factor tree is just a diagram that helps you keep track of multiple factoring steps. So let's look at our first example. It says, what is the prime factorization of 30? So what is the prime factorization of 30? So in order to make this factor tree, I'm going to write 30 at the top. And I'm going to create 2 branches, get it? Coming off of that 30. Now what I need to do is I need to think about 2 factors or 2 numbers that I can multiply together to get 30. Something that I do that's just easy for me, I see that 30 is even. And whenever I have an even number, I know without a doubt that 2 is a factor of an even number. So 2 is going to be one of my factors. And I can multiply 2 by 15 to get 30. Now let's start with 2. What can I multiply together to get 2? That's right, just 1 and 2, which makes 2 prime. So I'm going to circle it. Because one thing that we have to remember, we have to keep going until all of our numbers are prime. So let's look at 15. What can I multiply together to get 15? So I have 1 and 15. But is there something else? Yes. I can multiply 3 and 5. So I'm going to make 2 more branches, and I'm going to multiply 3 and 5. So now let's see, are 3 and 5 prime numbers? You have to ask yourself, are there any other factors, are there any other ways that I can multiply to get to 3 other than 3 times 1? And that answer is no. Same with 5. So I am finished. I've completed the prime factorization of 30. Okay? Now, you're probably asking, well, what if I didn't want to use 2 and 15? Am I still going to get the same answer? Well, let's try it. So I have 30. And what if you wanted to use 3 and 10? Because, again, there are multiple ways to get to some of these numbers, and 3 times 10 is one of those ways. So is 3 a prime number? That answer is yes, so I'm going to circle it. Now let's look at 10. Is 10 a prime number? No, it's not. So I'm going to create 2 branches coming off of 10. Now what can I multiply together to get 10? Hopefully you're thinking 2 and 5. So let's write those down. 2 and 5 are prime numbers, so I'm going to circle them. So how we write these are, let's look at this first example. I have 2 times 3, I'm not going to use that, times 3 times 5. Whenever you write the expanded form, remember expanded form from Monday also, okay? Think of it like an accordion. You stretch it out, you lengthen it out, okay? 2 times 3 times 5. You have to put it in order from least to greatest. So on my next problem, when we did 3 and 10, I have 3, 2, and 5, but that's not in order from least to greatest, so I need to put it in order from least to greatest. So 2 times 3 times 5. If you notice, these are the exact same. So it does not matter what factor you use, as long as you factor it all the way to its prime numbers. So my expanded form is 2 times 3 times 5. Now we need to turn this into exponent form. So if we notice, I do not have any repeating numbers, which means my exponent form is just the same as my expanded form, 2 times 3 times 5. All right, let's move on to number 2 for another example. So what is the prime factorization of 24? So again, I'm going to create a factor tree, and all the factor tree is just a diagram. So I have 24 at the top, and I want to draw 2 branches coming off of the 24. So I want you to think about 2 different, or 2 numbers that I can multiply together to get 24. Again, like I said on the first one, I see that 24 is even, so I'm just going to use 2 to make it easy on myself. And I also know that that's a prime number. What times 2 gives me 24? Hopefully you're thinking of the number 12. Now, is 12 prime? No. So I need to draw 2 more branches. 2 more branches. I again notice that 12 is even, so I'm going to pull that 2 out. And I know that it's a prime number. So 2 times what equals 12? Again, I hope you're thinking 6. Now, is 6 a prime number? That answer is no. So I have to draw 2 more branches. I have to get all the way down to where I get all prime numbers. 6 is even, so I'm going to pull out that 2. And 2 times what gives me 6? 3. I know 2 and 3 are prime numbers, so I'm going to circle them. So now I'm going to write the expanded form. And all I do, again, when I write my expanded form is I take all of my circled numbers and multiply, or put a multiplication symbol in between them. So 2 times 2 times 2 times 3. So that's my expanded form. Now, to turn this into exponent form, again, guys, we have already done this. We have already done it. So this is not new information. So I see that I have 2 that is multiplied by itself 3 times. So I'm going to turn that into one of my terms. So I have 2 as my base and 3 is my exponent. And that is 2 to the 3rd power is the same thing as saying 2 times 2 times 2. But now I have times 3. But I do not have any repeating 3's. And so it looks just like that. 2 to the 3rd power times 3. Hopefully this is starting to make sense. We are going to do some more questions on the back. So go ahead and either scroll down or flip over. Do what you need to do. Okay? And what I would like for you to do is I would like for you to pause the video and I would like for you to try what is the prime factorization of 180. And once you finish, unpause and see if you get the correct answer. So hopefully you got the same answer that I did. So I have 180 and I noticed that that's even, so I pulled out a 2. 2 times 90 is 180. When I factor out 90, I got 3 and 30. Could you have done something else? Yes, absolutely. 30 is not a prime number, so I have to factor that out, and I got 3 and 10. Could you have done 6 and 5? Absolutely. Could you have done 2 and 15? Absolutely. As long as you factor it all out to get the prime numbers. So at the end, I'm left with 2 times 2 times 3 times 3 times 5. So the one on the left is expanded form, and then I turned it into exponent form. I noticed there were 2 2's and 2 3's, which all of that is 2 squared and 3 squared, and then times 5 at the end. Hopefully you got that correct. If you didn't, I hope that you see why you got it incorrect and make that change. Okay, we're going to move on to the middle one. So sometimes you're going to get problems like this. So it says the prime factorization is 3 squared times 5 squared. What number does this describe? So sometimes you are going to have to go from you have a composite number and you have to find its prime factorization, but sometimes you're given the prime factorization and you have to find that composite number. So let's go over how we do that. So first thing we do, we take the prime factorization in exponent form and we have to turn it into expanded form. Okay, so 3 squared, all 3 squared is 3 times 3. And all 5 squared is 5 times 5. So 5 times 5. And now guess what? I'm just going to solve. 3 times 3 gives me 9. 5 times 5 is 25. And now I need to solve. So 25 times 9. 9 times 5 is 45. Carry my 4. 9 times 2 is 18. Plus 4 is 22. So my answer is 225. 225. All right, let's move on to the third one. So it says, what is the prime factorization of 80? I would like for you to pause the video and try it yourself. And then once you finish, come back and see if you get the correct answer. So hopefully you get 2 to the 4th power times 5. Okay, so I did 80 and I picked 2 factors, 2 and 40. 40 is not prime, so I have to keep going. I picked 2 and 20 are factors of 40. 20 is not prime, so I had to pick factors of 20. I did 2 and 10. 10 is not prime, so I have to keep going and I get 2 and 5. The expanded form is 2 times 2 times 2 times 2 times 5. And I see that I have 2 repeated 4 times. So 2 to the power of 4 times 5. Hopefully you got that right. If you didn't, I hope you see why you got it wrong and then you can make that change. What I would like for you to do now is go directly underneath that, and I want you to try this problem for yourself. So the prime factorization is 5 times 7 squared. What number does this describe? So go ahead and pause the video. Try this for yourself, and then come back to see if you get the correct answer. So hopefully you got 245. Again, like the problem that we have done before, 2 problems ago, we have to take the prime factorization, the exponent form, 5 times 7 squared, and we have to turn it into expanded form. So we got to lengthen it out, right? Like an accordion, like we said earlier. So 5 times 7 squared, we know 7 squared is 7 times 7. So we have 5 times 7 times 7. And then we're just going to multiply all of those together to see what our composite number is. So I just did 7 times 7 is 49. And then 49 times 5 is 245. So hopefully you got that same answer. If not, see what you did and compare it what I did. And maybe you can figure out what you did wrong. So that is all of our notes for the day. I hope you understand this a little bit. If you don't, there's a lesson in Schoology. There's another video in Schoology that maybe can help you understand it a little bit better. As always, feel free to reach out if you have any questions. You have a great day. Bye, guys.